Next up, we got to talk about right triangles. Today, it's a lot about setting stuff up for the things that we're going to do with all this stuff. And then on Thursday, we're going to have a lot of lab work where we're going to make some calculations and we're going to make some measurements. But right now, we've got to have the naming of parts. What do you think I'm talking about when I'm talking about a right triangle? What must be going on in a right triangle? One of the angles is a 90-degree angle. Perfect. So a right triangle just means one of the angles is 90 degrees. Could I have two 90-degree angles in there? I said one of the angles. Could I have another 90-degree angle? Why not? Why not just make this one 90 and this other one 90? Wouldn't have a triangle, right? There's two sides that just be like pointing straight up towards infinity. And we're like, oh, do they meet at infinity? Then things get really weird. That's a different kind of geometry entirely. It's not that it's not possible. It's just a different kind of geometry. We're going to deal with Euclidean geometry, which is the one that we mostly think of. So you're right. In Euclidean geometry, the one that we're dealing with, I can't have another angle that's 90 degrees because I wouldn't be able to have another angle up here. How many degrees can we have in one triangle? 180. You guys know so much already. And it makes sense. If I take a 90 here and a 90 here, this top one, these two can't meet, no angle, 0 degrees. I've used them all up in those two 90-degree angles. So it kind of makes sense. The sum of the angles in any triangle is 180 degrees. Sum of the angles in any triangle is 180 degrees. Awesome. We have names for things. I've got that right angle. And remember, one of the things that we want to have, a relationship we want to establish is an angle and the side opposite that angle. So I'm going to predict that we all, most of us have more knowledge. What do I call the side opposite the right angle? Hypotenuse. Awesome. We have now used the word hypotenuse. We've got a right angle, a right triangle. We know the sum of the angles is 180 degrees. A hypotenuse is going to be the side opposite the right angle. What's another thing that we know about right triangles? I know that's a super general question, but I'm predicting that some of you know what I'm going to say next. Oh, there's going to be like, yeah, we're going to talk about opposite adjacent. What's a theorem that I'm going to talk about? Pythagorean theorem. Pythagorean theorem is a thing that we know about the sides in a right triangle. What says the Pythagorean theorem? Awesome. Which one is C? As long as we remember that, that is our modern way of saying the Pythagorean theorem. If you say a squared plus b squared equals c squared, everybody will know what you're talking about. So the Pythagorean theorem in modern times, we get to use the algebra. And you're like, oh, when am I going to use algebra? Like every time you say the Pythagorean theorem, you know, a squared plus b squared equals c squared. I can assure you Pythagoras did not say it this way because he didn't have algebra. You want to revolutionize the world? If you go back in time, just start teaching people algebra. Even if you're like, oh, I'm not very good at algebra. It don't matter. They didn't even have it at all. Oh, and if it's like ancient Rome and they're like all using Roman numerals, make sure you tell them that they're idiots for having such a horrible number system. How did you get so far with such a useless number system? And then show them how numbers work. It's like, well, this is a number system. It's based on 10. Then they'll be like, oh, why didn't you use 12? Then it just like, look at them like this with disgust. Ugh. Even though it would be better if we used 12. That's beside the point. The Pythagorean theorem says that the sum of the squares of the legs of a right triangle equal to the square of the hypotenuse. Pythagorean theorem says the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Or, using our awesome algebra language, a squared plus b squared equals c squared. So a and b are legs of the triangle. And c is the hypotenuse. It's the specific side that's opposite the right angle. The other two are just legs or sides of the triangle. I don't know where I picked up the language calling them legs, but I'm stuck with it now. I think I'm too old to think. Notice that for the sides of my triangle, I use lowercase a, p, and c. A common thing to do is to call the vertices, name the vertices with capital letters. So a common way to name things is to name sides with lowercase and vertices with uppercase. This works as long as we're writing stuff down. It's a little inconvenient when we're talking. The other thing that's kind of inconvenient is since we just have a triangle, each vertex, each of the vertices is just one angle. So we start naming the angles with uppercase letters, even though we're talking about a vertex. So we try to do this in a way that makes sense. The vertex and thus the angle the vertex and the angle opposite side A will be angle A. I really hate that it's the same thing. It's capital though, right? So it's different. If lowercase b is one side, the angle opposite lowercase b is angle B, uppercase B. And that would make the right angle capital C. It's even worse with C because C, lowercase c and capital C look the same. I suppose if we're speaking, we could just shout A at the next stop. Opposite side A is angle A. But then my dog will be on, what? I was not climbing up on the chair to bark out the window. Actually, don't say A to my dog. Say off. He's like, oh, but the mailman. I don't get mad at my dog when he does that because he's doing his job. I mean, he was bred to be like, oh, someone's on our property. I got to go bark at him. Michael, you really don't have to do that. He's like, oh, my genetics say I do. Any questions? This is a standard thing that we're going to do. A opposite A, B opposite B, C opposite C. Even if C is not a right angle, this is how we're going to set it up. Now, this is really inconvenient because I'm like, oh, A opposite A. I'm like, oh, which one is the side? I'm like, oh, well, A is the side and A is the angle. It's like, oh, but earlier, didn't you say A was the side and A was the angle? I'm like, oh, no. A is the side and A is the angle. See how it doesn't translate very well? So one of the things that we like to do is instead of using uppercase letters versus lowercase letters, we switch to lowercase Greek letters for the angles. It also looks fancier. So alternate. Lowercase Greek letters for angles. If we're doing this ABC scheme, the triangle ABC, we could say A is alpha. Or we could use beta or gamma. If I need all three, these are the three that I'm going to use. Alpha, beta, and gamma. I mean, alpha, you just make a goldfish and like, whoop. I start up here and then go backwards like this. Some people start down here and then go up that way. That's really weird. I'm just kidding. It doesn't matter. And for beta, it's like a B, but with like an extra tall and it's like rounded. So don't be like all down and then back up. Just go straight up and then make a 3. So it's like a 13 where the 1 is slipping down. And gamma is just like an alphabet turned 90 degrees. So whoop. Yes. No. Thank you. What's that? Yeah, we use for gamma for C. So that would be A, sorry, for alpha, that'll be for A, beta for B, and gamma for capital C. Kind of, but the top has been cut off of it. It's like an 8, but like take the top off of it. We don't close up the top of it. Yeah, it's like an alphabet turned sideways. Yeah, it's like a ribbon. Yeah, alpha is a ribbon sideways. Gamma is a ribbon upside down. Beta is a little bit tragic because like I'm trying to train my brain to see beta as like a 13, but I'm usually looking at it kind of at this from the side, so it looks like the top half of a heart, and it's been like cut in half. So it becomes kind of like emo and tragic. Yeah, or half of a butterfly, and it's like it's always half of something that's pretty. And I'm like, oh, it's kind of tragic. Extra puff. Yeah, I don't know. Everything else starts getting, it starts with B, so it starts becoming, not safe for work. So if we need all three of our angles, we want to come up with names for all three angles, we use alpha, theta, and gamma. And so because we want to use a squared plus b squared equals c squared, that means gamma in a right triangle should be the right angle. Doesn't have to be, but it's really weird if you start messing with how things go. It's like all the controls on your car should be the same, right? This is where the turn signal goes. So if the lights are like one on the end of everybody should just put the lights on the end of the stalk or the wipers on this stalk. They shouldn't like mess with that. My wife's other previous car had like just one stalk. And so I'm like, oh, how do you turn anything else on? And she's like, oh, it's on this stalk. There's like one stalk. I'm like, oh, dodge, you dicks. It's like completely out of balance. Yeah. So if we just need one, we typically use different. Sometimes we use theta. So you just make an O, but keep going and cut it in half. Just make a 0 and cut it in half, like straight across the middle. That's a lowercase theta. And our other favorite one to use is phi. So make a smaller circle with a vertical line through it, and that'll be a lowercase phi. Or phi. So theta and phi. Theta and phi. Now it's not quite an 8 because you make the whole circle and then just cut back through it. So you kind of make the whole circle and then cut back through it. It's more like a South Park Canadian with his eyes closed. It's an 8 that kind of like let the belt out a little bit. Oh, so much better. I always like to take time to talk about how like I draw them, because otherwise they just like show up. And so to make these like an alpha. Plus it brings me back to like grade school when you were like learning how to make letters and you had that like the paper with like the extra line in the middle so you could see where it is. Yeah, so you can make sure that everything. Yeah. All right. Any questions? All right. So one more thing. There's one more thing. It's like a big thing to do at the end, but that's my favorite way to do things. Now notice that we've got two facts about right triangles. Number one, the sum of the angles in a triangle is 180 degrees. We also have the Pythagorean theorem, a squared plus b squared equals c squared. Notice that our two facts, one of them is all angle, and the other one is all sides. Sum of the angles, that's all angles. Pythagorean theorem, all sides. We need some kind of relationship between the two. We need to connect the angles and the sides. We need something that connects measuring angles with measuring sides. Because remember, all we're doing in trigonometry is metry some trigs. So we need a connection between sides, between, not between. Sides and angles. Exclamation point, because this is important. And I'm also going to label this page 2 of 2 to promise you that I'm not going to have a third page of notes. Cite that as well. So enter trigonometric functions. So for our purposes, trig functions, we introduce them in right triangle trigonometry. This is going to be a connection between angles, measuring angles, and measuring sine. We're going to start by applying this to right triangles. Rather than label my sides A, B, and C, and my angles alpha, beta, and gamma, I want to use the names of things. I know that the side opposite the right angle is the hypotenuse. And we're going to abbreviate that HYP for hypotenuse. We're not going to speak the abbreviation. We're going to say hypotenuse, but we're going to write hyp. I'm going to pick one of the angles and name it. Since I'm only picking one of the angles, I'm not going to do alpha, beta, and gamma. I'm just going to say this angle down here, this is angle theta. Theta is the most common, right? It'd be like using X. Once I pick one of the angles, I can actually give distinct names to the other two sides. Once I pick one of the angles, I can give distinct names to the other two sides. The hypotenuse, always the hypotenuse. But I can refer to this side as the side opposite theta. And we'll abbreviate that op. That's the side opposite theta. Some of you know this already. What am I going to call the other side? Adjacent. So this is the side opposite. When we talk about opposite, it has to be opposite in reference to some angle, but we're not going to say that part. Right? So this is op is going to be the side opposite theta. And adj is going to be the side adjacent to theta. Theta. Spelled A wrong. You should be concerned. I just spelled A as H. If I got 100% in the class, what did you get? H. My teacher couldn't spell A. The three trig functions that we're going to start with are sine, cosine, and tangent. Sine, cosine, and tangent. They have abbreviations. Now, when we write, the abbreviation for sine is SIN, which we pronounce as sine. When we talk about sine, you have to say sine of an angle. We can't just say sine all on its own. We have to talk about sine of an angle. So we're going to say sine of theta. Because we're writing, we're going to put our theta, the argument of the trig function, in parentheses. We're going to use grouping symbols because this is a good habit to get into. Because order of operations is eventually going to show up, we're going to use parentheses around the argument of our trig functions. Sine, cosine, and tangent are all ratios of the sides of the triangle. Anyone know what sine is? What ratio this is? Opposite over hypotenuse. You keep raising your hand, so that's okay. I didn't ask, I never specified any kind of rules for responding. I just like throw out questions. Sine is opposite over hypotenuse. Anyone know cosine? Adjacent over hypotenuse. And what is tangent? So if you guys know all this stuff, no, I'm happy. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are more. There are many more. There's actually more than 3 more. But ever since we started having calculators, we didn't need like the other 11. The ones with the negatives, those are inverses. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you have to remember these ratios. Remember that opposite and adjacent only make sense in reference to an angle. So we have to have an angle labeled before we can decide on opposite and adjacent. Otherwise, they're just legs. But you have to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are a lot of ways to remember this. Some people remember SOHCAHTOA, because it's SOHCAHTOA. So SOHCAHTOA. I was taught this in the 80s, and the version of the way I was told to remember this was super racist, so I'm not going to do it. But it was SOHCAHTOA. The other one is if you just remember sine, cosine, tangent, that's the order that we always use. You can remember OHAHOA. Oh, heck, another hour of algebra. So that's another way. You could use my personal favorite mnemonic device. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. That one's a lot less interesting. Yeah, I just remember the definition. Never good at it. This is because I'm old and they have to be identity for over a very long period. Sometimes I leave off the theta. That's if you want to be cool. It's like, well, sine is opposite over hypotenuse. That's like if you're going to be cool. If you're like, oh, sine of theta is opposite over hypotenuse. Like, oh, look who's all fancy. And it's kind of like snobby, you know what I mean? So if you want to be cool in just like casual conversation, the sine is opposite over hypotenuse. Even though sine by itself doesn't make sense. Of course, if you're the person that's like, oh, when someone says sine is opposite over hypotenuse, you're like, oh, don't you mean sine of theta is opposite over hypotenuse? Then the proper response is to just pee your pants right on the spot. I'm just kidding. That's not the correct response. And now, because I wrote phi in my triangle. So what you need to do is get like a 3x5 card with a triangle drawn on it and put phi as the angle. And like, don't you mean sine of theta? And you're like, oh, no. Just sine is opposite over hypotenuse. The name of the angle it's not important. You know what I mean? That's okay. It's my job. Last thing today. Here's what this does for us. It gives us a connection, a relationship between an angle and the sides in a triangle. A very specific right triangle. I have to work to generalize this, but that's our way in. We have a relationship between angles and sides. We've got one that's all angles. Some of the angles is 180 degrees. We got one that's all sides, Pythagorean Theorem. Now we've got a connection between the angles and the sides. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. How's everybody okay? If we started out at maximum okay, we're probably worse now. So if you're like, well, I'm really kind of not okay, that is the correct answer. If you're like, oh, I'm not sure where this is headed, I'm a little bit confused, that is the correct answer. It's the first day. What am I going to do? Give you the final now? That'd be crazy. Anyway, clear your desk. We're going to have a final exam right now. Just kidding. If you're like not okay because like, oh, class is so boring and you talk too much, in future, I get to talk less because now we're establishing some knowledge and some stuff we can work with. Any questions? Comments? Thoughts? Does everybody have a phone, a smartphone, that has a measurement app on it, where you can say, turn on the measurement app and say, figure out how long this table is, approximately. There is an app that you can get on Android phones in that is a measurement app, and you could just use it to use the camera, and it could measure. You could use it to measure length. So if you can make the phone do that, then do that, because we're going to be measuring some stuff. If not, don't worry. Someone will be able to. A significant number of us will be able to, and we'll just group up, and we're going to measure some stuff and calculate some angles. All right, that's it for today. I will see you all on Thursday, and we're going to have this a couple of days. And thanks for playing.